Assalamualaikum guys, today we will see how to plot complex exponential in Matlab, and we will observe its behavior with positive and negative values of sigma. As I have already told in my previous video that this is the complex exponential function where A is the amplitude, sigma is the real value, omega is the imaginary value, and J is representing that omega is the imaginary value, and omega is equal to 2 pi f, and T is the time for which I want to plot. And this is the equation showing that the exponential function in the form of sinusoidal function, and it's showing that its real part is going to be as cos signal, and its imaginary part is going to be as sine signal. Now move to Matlab. Okay. Here first of all I will define time for which I want to plot my function using the function line space, and its first argument is going to be the minimum value, second is going to be the maximum value, and third is going to be the number of values I want, including these values in this range. The second thing is I'm going to define the function a into exponential of sigma plus omega is equals to 2 pi f, 2 pi f, which is frequency, and this is imaginary value. To show that this is imaginary value, in Matlab you can put I, and it's more convenient if you put 1i, and this whole is going to be multiplied with t. Okay. Now I'm going to define the values I have used in this equation function. A is amplitude, you can set its value, any value, 2, 3, 4, let it be 1, and sigma, okay, give it some positive integer value such as 2, and frequency, the number of cycles per second, and equals to 2. Okay, you can set these values whatever you want. Okay, these are not fixed 1, 2, 2. Okay, the next thing is to plot something. First of all, I need to call the figure function, which is going to create a window on which my plot will appear. For 3D plot, I will use plot3 function, and its first argument is going to be time, and second is going to be the real part of this function, which I will get using the real function, and imaginary part of this function, which I will get using the image function, and you can set its color and set the line width of your curve, the curve that will appear in your plot. Now I will call figure again, as I'm going to plot 2D plots of imaginary and real part of this function separately. For 2D plot, I will use the plot function. I will pass time and the real part of this function, and I will set its line width. You are independent of this, whatever width you want to set for your plot, whatever line width. And same for imaginary part, except that here I will pass number 3, and this is figure 3 and imaginary function. Now click on run. So here's an error that I have misspelled the function that I have used. It is lin space. Now run. Okay, your 3 windows are going to open. As we know, our figure 1 is the 3D plot of this function. Let's first have a look at this by rotating it. Okay, you can see that with the positive value of sigma, the function is gradually growing. It is exponentially growing. Okay, your function is exponentially growing, and you can observe it and in any angle. Okay, So as we have also seen in a linear exponential function, like in the plot of real exponential function, that with a positive value of sigma, it exponentially grow. Similarly, in complex exponential function plot, it's also exponentially growing. Now let's see the real part of this function. This is real part, and this is the imaginary part of this function. And you can see that it is at 0, it is 0, and it is the figure 3 is imaginary part. As you know, the figure 3 is imaginary part of this function, and what we saw in the Euler equation, that its imaginary part will be same as the curve of sine function, and we know that sine is 0 at 0. Now look at its real part. Its real part is 1, its maximum at 0. And as we know that its real part was going to be as the cos function, and the cos function is maximum, which is 1 at 0. Okay, now by just changing the value of sigma, making it negative integer, let's see the behavior of exponential function, what it's going to be. Figure 1 is going to be the 3D plot, and by rotating it also, you can see that with negative value of sigma, it's exponentially decaying. The complex exponential function is decaying with negative value of sigma. You can observe it by rotating it, and these are the real and imaginary parts. This is the real part, and you can see its real part was going to be as the cos function, and the cos function is 1 at 0, and it's 1 at 0. It's just like cos function, but it's decaying, it's exponentially decaying. And its imaginary part, the figure 3 was the imaginary part, and its imaginary part is going to be like sine function, and it is like when sine function, as sine function is 0 at 0, and it's gradually decaying. So guys, this was how to plot 3D plot and the 2D plot of complex exponential function with positive and negative value of sigma and the behavior respectively. I hope you have liked this video. Please subscribe my channel. Thank you.